Hi students, welcome to this video session. I remain Samuel Chukwu Emeka, aka Some Dumb for Peace. In this video session, we shall discuss quantiles, box plots, and outliers. So get to my website, mathematics, statistics notes. So we are going to talk about quantiles. I will post the link to the video after this recording. I will post the link to the video right here. We shall convert a data value to a quantile. We shall convert a quantile to a data value. Then we shall determine the 5-number summary of data. And once we do that, we shall construct box plots, otherwise known as box and whisker plots. So some textbooks you see it as box plot, some textbooks you see it as box and whisker plot. It means the same thing. So we shall construct box plots for a data set, and we shall talk about outliers. We shall determine outliers using fences. So what is a quantile and why are we learning it? Sometimes it is necessary to know the position of a data. So, it is necessary to divide the data set into equal sized groups. So quantiles are the cutoff points, those data values that, or the cutoff points that mark the boundaries between equal sized groups of data sets, or otherwise you can call it subsets. The following types of quantiles are our interests. Percentiles. When you talk about percentiles, you're talking about dividing the data set into 100 equal groups. The deciles is dividing the data set into 10 equal groups. Dividing the data set into 5 equal groups gives you quintiles. And dividing the data set into 4 equal groups gives you quartiles. So these are known as the measures of location. They indicate the location of data values. Like if we ask to find the 5th percentile, so what is the data value that corresponds to that 5th percentile? 3rd quartile, 4th decile, and the rest of them. So for us to know the exact location of a data value, we really need to arrange this data set in ascending order. We really want to do it by ascending order, though you can also do it in descending order, but you want to do it in ascending order. Why? Because ordinarily you start from small till you grow big, right? So you start from the kindergarten, then the 1st grade, the 2nd grade. Okay, most things in life are from small to big, okay? So in ascending order. And the formulas we shall also list deals with the values that are less than the main value, which will make sense with ascending order. I would like you to complete this table. I will give some examples and then I would like you to complete this table. When we talk of the 10th percentile, so we see that percentile is dividing a data set into 100 equal groups. So of course the first group will contain, the 10%, second group will contain the 20%, and the rest of them. The first group will contain 1%, second group 2%, third group 3%, okay, because it's 100 equal groups. With decile, you talk of dividing the data set into 10 equal groups. So the first group contains 10%. Okay, which means, of course, this first decile contains up to 10% of the group. Second decile contains up to 20%. So the 10th percentile is what we call the first decile. 20th percentile, second decile. 30th percentile, third decile. 40th percentile, fourth decile. Like decades, when you talk about decade, it means 10. Okay, 10 years, decade. So decile. Then you talk about a quintile. The first quintile, with quintile, you're dividing the group into 5 equal parts. So let me illustrate this more. Let me pull up my notebook. Click on new section. And I'm just going to type in quantiles here. Let me get my pen. I'll prefer this pen. Let me get this pen right here. So you're talking of, dividing a data set into 5. Okay, so first, second, third, fourth, and then fifth. First, second. So when you do this, this is quintile. So you see that this is like 20%. 20, 40, 60, 80, 100. So the first quintile is the 20th percentile. Okay, the first quintile is the 20th percentile. Okay, remember that quantiles is percentile, decile, quintiles, quartiles. These are all quantiles. Quantiles are just equal groups. Then when you talk of quartile, you're talking of just 4 groups, 4 equal size groups. Okay, 1, 2, 3. First here, second, third, and fourth. So up to this 25, you see this is now 25%. 25%, if you're gonna break it down in percent. So up to 25% is the first quartile. Up to 50% is the second quartile, or the middle, what we call the middle quartile. Up to 75% is the third quartile. Okay, and then you have the fourth quartile. So I want you to complete this table. The way you could do it is by proportional reasoning. You can use a proportional reasoning to do it. For instance, if I want to find what quartile is the 10th percentile. Okay, so well, I know I have my percentiles, and I have my quartiles. So you could do proportional reasoning. Okay. So I have that my 25th percentile is my first quartile. Okay. 25th percentile is my first quartile. So 10th percentile, what is it gonna be? The 10th percentile, you could do proportional reasoning. You could now do cross products. You could do proportional reasoning. So 10 percentile, of course, will give you what now? Just 25 times x is equal to 25 times x is equal to 10 times 1. Okay, so your x will be 10 times 1 divided by 25. So what quartile will it be? Okay, you have a 0.4 because this is actually 2 over 5. 2 over 5, and that gives you 0.4. So 0.4 quartile is your 10th percentile. So I want you to fill it up, fill it up, and you can contact me whether for whether you got it right or wrong. Yeah, but can I play with it to know what percentile, just converting from quantile, converting between quantiles. Okay, what a quintile is the 30th percentile. Okay, now of particular interest is that our first quartile, Q1, we call it Q1. So anytime you come to anytime you see uppercase Q with a subscript 1 in statistics, it means first quartile or lower quartile. And of course, that is your 25th percentile. Then the second quartile or the middle quartile is your median, that is your 50th percentile. The third quartile or the upper quartile, Q3. Q2 is your median, Q3 is your upper quartile, and that is the 75th percentile. Okay, and if you convert it with this proportional reasoning, if you do it with this proportional reasoning, you will get it right. Okay. So let's look at the first set of our formulas here. If you want to convert a data value to a quantile, you want to convert a data value to a percentile, then you have to count the number of values that are less than that data value. You divide it by the total number of values and you multiply by 100. Whatever you get is your white percentile. To find the decile, you just do the same thing but multiply by 10 rather than 100. And whatever you get becomes your white decile. To find the quintile is the same formula, but rather than multiplying by 100, you multiply by 5. And that becomes your quintile. The same thing is applicable to your quartile, whereby you multiply by 4 rather than by 100. So when we talk about quartiles, okay, you could either use the formula for quartile, where you multiply by 4, or you could use the formula for percentile, where you multiply by 100. Depending on what you're asked to find, we shall look at an example on that. Then the second set of formulas is converting a quantile to a data value. So in this case, you kind of want to find the location or the position of whatever quantile you want to convert. So, and how do you find the location? Okay, in this case, you divide by 100. Here you multiply by 100. For the percentile, you divide by 100. Decile, you divide by 10 times the total number of values. So it's basically the same formula, but just know this particular one, when you want to convert a data value to a quantile, you have to multiply. And this basically you divide. You multiply by 100 if it's percentile, you multiply by 10 if it's decile. But here you basically divide by 100 if it's percentile, you divide by 10 if it's decile. And also here you divide by total number of values. Here you multiply by total number of values. Okay, here there is a rule here for this second set of formulas. When you find the position, this is the formula to find the position. Some textbooks will call it locator. Okay, some textbooks will use L. I don't want to use that. So I call it position, but it's the same thing. When you find a position, if you find an integer, then the position will be you add that position, whatever value you have in that position plus whatever value you have in the next position, and you divide by 2. Just as if you were finding your median, when you have an even set of data, Okay, to find the middle number, you have two numbers as the middle number. So you take the mean of those two numbers. So this is just as if you were finding your median. When you find that your x position is an even number, an integer. If it's an integer, then you want to find that x position from this formula, and then you find the next position. Whatever values you have in those positions, add it up and divide by 2. You could also say round down the x position, round up the x position, find those two values, and then take the mean, which means add those two values and divide by 2. If the x position is not an integer, then you just round it up. You round up that position and then find the value that corresponds to that position. Let us look at examples. Example 1 will deal with the first set of formulas. You want to, you have this: Timothy surveyed 36 adults in the city of Truth or Consequences, New Mexico. I like that name, City of Truth or Consequences. He sorted their ages as seen in the data below. Determine and interpret the quantiles of 65. So you're converting a data value to a quantile. You want to determine the quantile of 65. So you're going to use this first set of formulas right here. You use this first set of formulas here. Okay. In this formula, we have to find the total number of values, and then we also have to find the number of values less than 65. So you come over here, you count the total number of values. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 times 2 is 26. 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. So the sample size is 36. You now find the number of values less than 65. And of course, this is 26, then this is 27. 27 values are less than 65. So the percentile of 65 will be 27, because this means number of values less than x, divided by the total number of values, then times 100. So you do 27 out of 36 times 100. That gives you the 75th percentile. Let us interpret this. This means that if you divide this data set, okay, if you divide it into 100 groups, then 65 separates the lowest 75% because it is 75th percentile. Okay, the age 65 will separate the lowest 75% of the ages from the highest 25% of the ages. So, or you can also say that 75% of the ages are lower than 65, while 25% of the ages are higher than 65. That is the interpretation. The same way you do for decile. The only thing is that you multiply by 10. So it is the 7.5th decile, which means that if you divide this data set into 10 groups, okay, if you divide this data set into 10 groups, 65 will separate the lowest 7.5 from the highest 2.5. Okay, that is the same way you do that for quintile and quartile. Now, what if you were asked to convert you are now asked to find the 75th percentile. You are asked to convert a quantile to a data value. Second formula. Convert a quantile to a data value. So you would expect that the 75th percentile should give us 65. You would expect that the 7.5th decile should give us 65. You would expect that the 3.75th quintile should give us 65. And you would expect that the third quartile will give us 65. Okay, let's see here. From the formulas I gave you, the x position, the second set of formulas. So for the 75th percentile, it will be 75 out of 100 times 36, the total number of values. So you have 27, okay? This is the position. Now, because 27 is an integer, if it is an integer, then you find the 27th position plus the 28th position. So, and divide by 2. So you look at the 27th position here. This is 26. 27th position is 63. And 28th position is 65. See that? This is 26. 27th position, 63. 28th position, 65. When you do that and divide by 2, it gives you 64. Okay, so our 75th percentile or our third quartile is 64, right? But then when we did percentile of 65, it still gave us 75th percentile. So it should make sense that when we find the 75th percentile, it should give us 65 and not 64. Okay, and not 64, as we found here. Well, this is, some textbooks. Now, if you use this formula here, total number of values plus 1, instead of just doing, when you do white percentile over 100 times total number of values plus 1, and you still follow these rules right here, then you will get 65. You can try that on your own, okay? And some textbooks still use this. Some online resources you see still use this formula. Because then you would have let me pull up my calculator. Then you would have a calculator. Because then you would have 75 over 100, which is 0.75 times, instead of 36, okay, you will have 37. Because with this formula, it's 36 plus 1, which is 37. So you would have a 0.75 times 37. And that gives you 27.75. You round it up is the 28. You round it up because if it's not an integer, you round up. You round up. So you always round up if it's not an integer. We don't care whether it's 27.2. We don't mind. No. Even if you have 27.1, if it is not an integer, you have to always round up. So if we round up this to 28th position, we will have 65. Makes sense, right? Okay. But then there's a problem here. There's a catch here. When you are trying to find the median is always the 50th percentile. And for the median, we always have that set particular way of finding it. Okay. If the data set is even, it has to be two numbers, the mean of two numbers. Now, if the data set is odd, you just have one number as the median. Well, if you try to do median here, if you try to find the middle quartile or the median or the second quartile, in this case, the sample size is 36. Okay, so if you take away 17, okay, which is 34, so you have 18th and 19th position. 18th and 19th position. Okay, because you take away the first half, take away the second half, so that you have only 2 in the middle. And you have the 18th and 19th position. So when you do that, this is 13, 14, 15, 16, 17, 18, 19. So it's 44 plus 48 divided by 2. Okay, 44 plus 48 equal to this divided by 2. This is our median here, 46. Okay, now if we use this formula right here, 50th percentile, and we use this. So we'll be looking at 50 over 100, which is 0.5 times, now 37 instead of 36, 37. And that gives us the 19th, if we round up, 19th value. That is a problem. Big problem. Big problem. But if we did that 0.5 times 36, we will still be getting the 18th and 19th position to give us our median, which is 44 plus 48, 92, divided by 2, 46. Okay, but if we did that 0.5 times this formula here, times 37, we get 18.5. Round it up, 19th value. And 19th value is 48. Okay? 13, 14, 15, 16, 17, 18, 19. So 46 and 48 are two different things. It is a big problem. That is why I have issues with this formula. With this formula right here. But I still put it here in case you see it somewhere else. Okay? If you see it somewhere else, okay. And it might be from an educational institution. Okay? Just for your knowledge that I have a problem with this formula here. Now, some people say, okay, you know what? This formula is good for every other thing besides the median. For the median, just do it like that. But for this one, if we use this formula, then for this particular data set, we will get the 65 for this other quantile, for this percentile. But then, for the median, it becomes a problem. So there is still some confusion about this, that that this formula should apply, that this formula should not apply to the median. Or did I write that it should apply only to the median? Okay, that should not apply to the median. Yeah. So some textbooks still use it, but please, 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 don't use it. For this course, don't use it. Use this formula for this course here, this second set of formulas. Okay? So in case if you're looking at online resource or other YouTube videos or other textbooks and you see this formula, use it in that course, but don't use it for this course. Okay? So that is the way we find converting a data value to a quantile, and then converting a quantile to a data value. The next thing we shall talk about is what we call the 5-number summary of data. So the 5-number summary of data is your mean, your minimum, lower quartile, Q1, median or middle quartile, upper quartile, and maximum. So let's do some examples. And the nice thing about this video is I will show you how to use Statcrunch to get this. So I've already done this here. You're asked to find, of course, your minimum is your smallest number. This data set has already been arranged for you in ascending order. You can sort data if you have a big data set. Then you can easily sort your data with Statcrunch. But for this data, it has already been arranged for you. The sample size is 15. The minimum is 70. Then to find the lower quartile, of course, you use the formula. Like I said, you can use 1 over 4 or you can use 25 over 100 because the lower quartile is 25th percentile. So rather than saying 1 over 4, you could still use 25 over 100. And because this is a decimal, you round it to the 4th position. So 1, 2, 3, 4. The 4th position is 71. So that's why Q1 is 71. Okay? And that is the way you do the rest here. So this becomes our 5-number summary. In example 4, this one you round it up. Now for this one, for the median here, in example 1, for the median, you can use 2 over 4, which is the 2nd quartile. You can use 50 over 100, which is the 50th percentile. Okay, that's why you see me, some cases I use 25 over 100 to just let you know that you could still use it as 25th percentile, because 25th percentile is your first quartile. Okay, and 2 over 4 means your second quartile, which is your median. You can also use 50 over 100, okay, which is the 50th percentile. It is still your median. In this case, we got our 9. So it's the 9th position and the 10th position divided by 2. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 12. And then 10 position divided by 2. So our median is 14.5. We did our 9th and 10th position because if x is an integer, if the x position is an integer, you find the values in that x position and in the x plus 1 position and divide by 2. So that's why we got the 2 values, the first value for 9th and the second value for 10th, and we divided it by 2 to give us our median. Okay, and the Q3 is your third quartile, 3 over 4, or your 75th percentile. So let's look at how you can find this. I already did this here. We shall confirm from here. I think question example 3 is my question 17 on Statcrunch. I got it wrong so that you can I got it wrong on purpose, okay, so that I can show you here. Now this is example 3. I think it is the same data set. It's the same data set. And we did it by hand here. We did it by hand here. And it gave us this answer. Now I'm going to show you how you can do it with Statcrunch. So you open up you open up this data here. You click here, open in Statcrunch. And this is your, can close this. This is the following are speeds of cars. So I can just come here and just type speed. Okay, I can just type in speed. Now I'm going to go to start. I go to summary stats. I click on columns. And here I select the speed. That is the variable. And I need the minimum first. I click on minimum. Then you see here, it says, look at what it says here. Select more than one with shift plus click or control plus click. So I hold the control key on my keyboard. The next one is my Q1, lower quartile or first quartile. Then I need my median. The way you click it is the way it will appear. Then I need my upper quartile, Q3. And then I need my max. I need my max. Let's say you don't really want this, okay? You just want the percentiles. Of course, you can still do that. You know that the Q1 is 25 percentile, 25th percentile. You just put 25 and put comma. Then median is 50th percentile and upper quartile is 75th percentile. If you want to store it in a data table, you check this box. Otherwise, you just click compute. So when you click compute, this is what we got here. 70, 71, 74, 78, and then 79. 71, 74, 78. So this shows you, hey, that I think I made mistake in my upper quartile. Is that right? So that is why it is good to check your work with technology, you know, especially because you're taking this as an online class. So I check it again, 45 divided by 4, and that is 11.25. Now my 12th position I go back to count this again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so that tells me that, hey, Mr. C, you didn't write this well. That's what it tells me, that, hey, I didn't write this well, because here the 12th position is still 78, but here I wrote 79. Okay, that tells me that I made a mistake. So this is just for you to know, hey, that checking it with technology is still fine to do that. Okay, so I'm going to fix this. I'm gonna fix this after this video, so that you can see that the correct thing. Okay, but then if I still did that, like from this, it's still correct. But now I see that, hey, I made a mistake in writing this. So that tells you I'm human, right? I make mistakes. Now, technology helps us to now find out the mistake. So I will fix this right here by writing 78 immediately after this video. So that gives you exactly what we need. Now, the second one. So I'm going to just close this one, and I come here and I just type 70, 71, 74, and this is 78, and then 79, and you click that. Nice work. Okay. Now the next thing is box plots. So we shall go ahead and do box plots. We come over here, you open in Statcrunch, you come to graph, you click on box plot, and in this case I didn't rename it. I'll just put variable 1. That's fine. Okay, now for your normal box plot, you want to draw boxes horizontally. We will talk about fence and outliers in a moment. So you just want to check this, draw boxes horizontally. The nice thing about box plot, remember box plot, you use the 5-number summary of data to draw your box plot. So when you just point your mouse at this, it still gives you the 5-number summary of data. 70, 71, 74, 78, 79. You see that? So it still gives you the 5-number summary of data. So you now compare, you can compare which one is which. The minimum, of course, is a 70. So because the minimum is 70, A can be correct, B can be correct, C can be correct, D can be correct. Maximum is 79. A, B, C, and D can be correct. Then you look at this, check the median. The median is 74. So A is, by process of elimination, A is wrong. Process of elimination, B is wrong. Median is 74. Okay, that is this line here. Process of elimination, C is wrong, and then D becomes just your answer, and that is it. Okay, now let's do 16. I think I didn't make mistake in 16. Let's see. I'm gonna correct this after now. 16 is example 4. 16 is example 4. Okay. So when we did that, this is our 5-number summary of data. So I'll just go ahead and do this. I go to Statcrunch, open in Statcrunch. 16, what is my amounts of time? So I'll just name this as time in minutes. Go to start, summary stats, columns, time. Then I come here. Let me bring this up. I want my minimum first, mean I click on it first. I hold my control key. Okay, then I select Q1, lower quartile. I select the median, which is the middle quartile. I select Q3, upper quartile. I select the maximum. And that gives me the 5-number summary of data. I can also enter 25th percentile, 50th percentile, 75th percentile. And I click compute. If I want my data to store in data table, I check this box. Okay, in this case, it stores it in the data table right here. And you see it like this. So I have 5, 10, 14.5, 37, 64. Okay, and if you just want the percentiles, the quartiles, 10, 14.5, 37. Yay, I got this one right. Okay. I got this right. Okay. So that is the way you do it. We can close this. Put 5, 10, 14.5. I also got the previous one right. It's just that I did not write my data value, one data value correctly, which I will fix. Okay. All right. Now the box plot. You still open this, open in Statcrunch, and you can kind of do the same thing at the same time. So graph, box plot, time. I want to just draw boxes horizontally, and I want to just draw it horizontally. For now, I have not taught you use fences, so I'll just leave it like that. Okay. You always want to draw your box plot horizontally. Compute. Now I can check this. By visual comparison, you can also do visual comparison. You see that it's not going to be this one, no. But the best thing is to just do it minimum. The minimum is 5. Okay, so A is off, B is off, C is off. Minimum is 5. I'm sorry, I was looking at the first quartile, don't mind me. First quartile is 10. Okay, minimum is 5, so A could be there, B could be there, C could be there, and D could be there. The same thing with first quartile. Maximum is 64. A could be there, B could be there, C could be there. D is out for maximum. I look at this as, first of all, minimum, then I look at maximum, then I look at median. Okay, median is 14.5. It could be A. It's not gonna be B. So B and D are out. Okay, it could be C. Now let me check my Q3. Q3 is 37, and that will eliminate C. So I have only A. Okay. All right. So now the next thing we will talk about is other formulas: interquartile range, semi-interquartile range, and then middle quartile. Especially interquartile range. Why are we talking about interquartile range? Outlier. An outlier is an extreme data value. A data value that is either too high or too low from the majority of the other values in the data set. So they affect several statistics of data, including the mean and standard deviation, among others. Later on, as we proceed in this study, we shall talk about outliers. But for the standard definition of outliers, we could use interquartile range to define it. How do we do so? First of all, we establish what we call a fence. Just like you have your fence for cutoffs, like boundaries for determining outliers. So your lower fence will be the Q1, your first quartile, minus 1.5 times the interquartile range. And your upper fence will be Q3 plus 1.5 times the interquartile range. So a data value is an outlier if it is less than the lower fence or if it is greater than the upper fence. So a better definition would be a data value which falls more than 1.5 times the interquartile range below the lower fence or above the upper, below the lower quartile, below the lower quartile or above the upper quartile. We use the 5 summary of data to draw box plots. A box plot is a graphical representation of data using the 5 number summary of data. These are what we call box plots. Remember, we use the 5 number summary of data. First one is your minimum, second one is your lower quartile, third one is your median or middle quartile or second quartile, fourth one is your upper quartile or third quartile, and the last one is your maximum value. Multiple box plots are box plots you can construct on the same scale, okay? Where you have different data sets and you want to construct box plots on the same scale for you to kind of observe it, for you to kind of observe and compare the 2 data sets. You could use multiple box plots. And the modified box plots are those box plots that indicate the outliers. If there's an outlier, it will indicate it by points or asterisks. In this case, assuming there's an outlier here, if we go to open Statcrunch, if we open this data in Statcrunch, okay, I always like defining my variable, which is in this case your time. Now graph box plot. If you draw the box 6 horizontally, now you might use, if you check this box, use fences to identify outliers. Compute. There's no outlier here, so you're good. Now, if there was an outlier, then of course the fences. Remember that the fences is the lower fence. If it's lower than the lower fence or higher than the upper fence, then it has to be an outlier. So with modified box plots, if there was outliers, it will indicate it by points or asterisks. Then the horizontal line, the solid horizontal line, extends only to the minimum or maximum value that are not outliers. So if the minimum was an outlier or if the maximum was an outlier, the solid line would not extend to it. So that is what it's saying. Okay. Let us look at an example of this, of multiple box plots and modified box plots. We have question 18. So it says you should use the same scales to construct box plots for the pulse rates of males and females, and determine the box plot for the men's. So you will click here. Men's pulse rates. You have only full data sets. So let's open this in Statcrunch. So you have men's. Let's extend this. Let's expand it so you kind of see it well. I'm gonna drag this. Okay. So these are men's pulse rates and these are women's pulse rates. You go to graph. You go to box plot. And which one did they ask first? Men. So you could check men. So you click both of them. Of course, you have to press your control key. Click both of them. And then use, here I know they didn't ask you for modified box plot, but I'm just going to do that. I'm going to use fences to identify outliers just to show you in case if there's an outlier. And then you click compute. So here you see there are 2 outliers here. See that? See there are 2 outliers here. Okay. But this is still your 5 number summary of data. Here they gave you see here it tells you there are 2 outliers for the women. It's like the women came first, even though the man was first here. 40 values, the sample size is 40, 2 outliers, Interquartile range is 11. Of course, your interquartile range is your upper quartile minus lower quartile. Okay, that gives you 11. And of course, you know how we determine the outliers using that formula. And you have the 5-number summary of data. Here, you don't have any outlier. So, but here, you have 2 outliers. So, like this is a modified box plot. And these are multiple box plots because we use the same scale to construct them. So, what you have to do now is to compare, for the men. We're going to look at this for the men. So, we have, let's look at the minimum first, 46, and then maximum 90. 46 and 90, this is off. Well, this might be correct. This is off. B is off. 46 and 90. This is 50, so C is off. So it's here 46 and 90 might be A and D. A or D. Okay. 46 or 90 might be A or D. And then you look at because this is the men's, and you look at this is approximately symmetrical. This is almost symmetrical. You look at the median. The median is 66.5. Okay, which is possible this, but here the median is 70. So the answer tells you that this is A right away. Okay, tells you it's A. And that is the same way you do for B. Okay, that's the same way you also do it for B. All right. So finish up this, and if you have any questions, let me know. Thank you so much for listening, and you have a good evening. I also have some notes here that will be useful. Let me get here. Module 3 homework study guide. There you go. So if you want to know more, and I did video on this, know more about box plots and 5-number summary and also interpretation, I kind of did video on this. And this is and this will be the video here, module 3 homework study guide, and the video will be under the video is going to be under finite math module homework and exam study guide, and it's going to be module 3 homework study guide, in case if you want to look at it. All right, thank you for listening, and you have a good evening.